Google is expanding the capabilities of managed agents within the Gemini API, introducing background execution, remote MCP server integration, and more flexible credential management. To understand why this matters, you first have to understand what a managed agent is in the Gemini ecosystem. Essentially, it's a way for developers to call a single endpoint where Gemini doesn't just chat, but actually handles the reasoning, code execution, package installation, and file management inside an isolated cloud sandbox. Until now, these agents were largely limited by the nature of synchronous HTTP connections. Google is changing that with a few key technical updates. First, they've introduced background execution. Normally, Hugging Face has just released the third installment of its Profiling in PyTorch series, focusing specifically on the mechanics of the attention mechanism. To understand this, you first have to understand that attention is the engine of the transformer, but it is notoriously inefficient due to its quadratic time complexity. Developers use a variety of tricks to speed it up, but often these optimizations are black boxes. This new guide aims to pull back the curtain by showing exactly how different attention implementations look when viewed through a profiler trace. The team started by building a naive attention module. In plain language, this is the most basic way to write the algorithm. You multiply your queries and keys, scale the result, apply a causal mask to hide future tokens, normalize with. NVIDIA is arguing that the biggest bottleneck for AI agents isn't actually the model weights, but the data used to train them. To understand why this is happening now, we have to look at the gap between a chatbot and an agent. A chatbot predicts the next word, an agent executes a workflow. For an AI to actually navigate the real world, it needs to know how to handle a broken API call or a workflow it has never seen before. Without that specific training, NVIDIA claims we don't have agents, we just have autocompleters with tools. To bridge this gap, NVIDIA has released a massive suite of open data products under the Nematron umbrella. They've put out over 10 trillion pre-training tokens and millions of post-training samples covering domains like code, math, and agentic behavior. Because raw data tables are useless to humans, they built the Nematron post-training V3 prompt atlas. This is an interactive visual map where every point is a prompt sample. By clustering semantically similar prompts together, developers can zoom into specific regions. Hugging Face has announced that its Transformers modeling backend for vLLM is now as fast, or in some cases faster, than custom, handwritten vLLM implementations for many LLM architectures. To understand why this matters, you have to understand the porting tax. Usually, if a researcher creates a new model in the Transformers library, it's great for accessibility, but if you want maximum production speed, you have to manually port that model into an inference engine like vLLM. This means writing custom code to handle things like continuous batching and specialized kernels. It's a double work problem. You write the model once for the community, and then you write it again for performance. Hugging Face says they've effectively killed that tax. In an official announcement, they put their Transformers backend head-to-head against native vLLM implementations using 3 different Qwen 3 models. They tested a 4 billion parameter dense model on a single GPU, a 32 billion parameter dense model using tensor parallelism, and a massive 235 billion parameter FP8 mixture of experts model across an 8H100 node. The result? Hugging Face claims the Transformers backend met or beat native throughput on every single one of those tests. But how is this possible without manual porting? The secret is a dynamic rewrite process. Hugging Face and Amazon have just launched a deep link integration that allows developers to move from model discovery to active experimentation in SageMaker Studio with a single click. To understand why this matters, you have to understand the friction gap in AI development. For a long time, finding a great open weights model on Hugging Face was the easy part, the hard part was the plumbing. Moving that model into a production-grade environment like AWS usually meant a tedious manual process of navigating the AWS console, setting up domains, and wrestling with permissions. According to an official announcement from Hugging Face, this new integration effectively removes those hurdles. Now, when you're on a supported model page, you'll see two specific action buttons: Customize on SageMaker AI and Deploy on SageMaker AI. If you hit Customize, you land directly on the model customization page in Studio with that specific model already preloaded. If you hit Deploy, you go straight to the endpoint deployment page. But the real technical lift here is happening under the hood with permissions and quotas. The system now automatically provisions a new domain with a managed policy called Amazon SageMaker Model Customization Core Access. This gives developers immediate access to serverless customization jobs, including supervised fine-tuning, DPO, and reinforcement. Microsoft is essentially building an enterprise bridge to the open-source world by bringing a curated catalog of Hugging Face models directly into Foundry managed compute. To understand why this matters, you have to look at the friction point for big companies. Right now, if an enterprise wants to use a cutting-edge open-weight model from Hugging Face, they can't just click a button. They have to handle the GPU orchestration, the security scanning, and the runtime environment themselves. It's a massive operational hurdle that usually keeps corporate AI teams locked into a few proprietary APIs. According to an official announcement from Microsoft, they are solving this by introducing a curated collection of Hugging Face models that are refreshed weekly. These models are pre-staged in Azure, meaning the weights are already there, and the runtimes, things like vLLM, SGLang, and TensorRT-LLM, are built and scanned by Microsoft. The mechanism here is managed compute, which is a GPU platform as a service. Instead of worrying about the specific GPU topology or whether a model lands on one accelerator or several, the developer just defines the parameter count and context length, and Foundry handles the hardware underneath. Hugging Face and SkyPilot have officially teamed up to eliminate the cross-cloud transfer tax by allowing AI workloads to run on any cloud while storing data on Hugging Face with zero egress fees. To understand why this matters, you have to look at the current GPU landscape. Most teams don't get all their compute from one place. They might have a reserved block on a hyperscaler, a cluster on a neocloud, and some on-prem racks. But while compute is fragmented, data usually isn't. Traditionally, if your data is in an AWS bucket but your available GPUs are on another provider, you pay a steep price just to move your own data to your own compute. In a joint announcement, Hugging Face and SkyPilot detailed a new integration that makes Hugging Face storage a first-class backend for SkyPilot. Essentially, you can now mount a Hugging Face bucket or any hub repo into a SkyPilot job using a single HF//URL in your existing HF_token. The technical magic here happens through a Fuse backend called HFMount. When you use the mount mode, the system doesn't download the entire dataset first. Instead, it uses lazy reads. When your code asks for a specific piece of data, Hugging Face has just released LeRobot version 0.6.0, a major update focused on closing the robot learning loop by introducing policies that can actually imagine the future before they act. To understand why this matters, you have to understand the current struggle in robotics, the gap between a model that looks right in a simulator and a robot that actually works in a messy living room. Most AI robots act on immediate reaction. They see a frame, they move. But to get to true autonomy, robots need a world model, the ability to predict what will happen next if they move their arm a certain way. In this release, Hugging Face PhotoRoom is pulling back the curtain on the data strategy behind their PRX model, revealing a pragmatic approach that prioritizes breadth over perfection during the pre-training phase. To understand why this matters, you have to understand the current tension in AI training. Most developers obsess over clean data, but PhotoRoom is arguing that over-filtering for aesthetics too early actually cripples a model's understanding of the world. They are essentially separating the act of learning how to see from learning how to be tasteful. According to an official announcement from the team, the PRX pipeline follows a specific sequence. They assemble a mix of public and internal datasets, recaption those images using a vision language model, and then convert the result into a streamable corpus. The team's core philosophy is that pre-training is for breadth, while fine-tuning is for taste. They explicitly state that over-filtering for aesthetics during pre-training would narrow the distribution, costing the model compositional variety it cannot recover later. Instead of scrubbing imperfect images, they use long, faithful captions to describe everything, including logos or advertisements. By doing this, they turn visual noise into controllable attributes that a user can actually prompt for or away. Technically, they are balancing two different data formats to solve the rigidity problem. They use LLMs for feature engine. Hugging Face is fundamentally changing how custom AI kernels are packaged and distributed with a major overhaul of its kernels project. To understand why this matters, you first have to understand what a kernel is in this context. These aren't operating system kernels, they are specialized pieces of low-level code designed to run specific mathematical operations on GPUs to make models faster and more efficient. Until now, distributing these has been a fragmented, often risky process. Hugging Face says they have almost completely redesigned the project to make it frictionless and secure. The most visible change is the introduction of a new kernel repository type on the hub. This means kernels are now first-class citizens, allowing users to see exactly which accelerators, operating systems, and backend versions a kernel supports before they even download it. But the real meat of this update is security. Because kernels run native code with the same privileges as the Python process loading them, a malicious kernel can do serious damage to a machine. To fight this, Hugging Face is using NICs to ensure builds are pure and reproducible, and they are embedding the SourceGit SHA1 directly into the kernel. They've also introduced trusted publishers. By default, the kernels package will only load kernels from organizations the community trusts to act in good faith. Deutsche Telekom is attempting to move beyond simple AI adoption to become one of the world's first AI-native telecommunications companies. To understand why this is a massive undertaking, you have to look at the scale. We are talking about a company serving over 300 million customers across Europe and the US with a workforce of more than 200,000 people. When you operate at that magnitude, a simple software update isn't a transformation, it's just maintenance. According to an official announcement from OpenAI, Deutsche Telekom is treating this as a fundamental redesign of their entire operating model. They aren't just handing out licenses, they are rewriting how decisions are made and how services are delivered. The numbers show a massive appetite for this shift. The company reports over 50,000 monthly active users of ChatGPT and API tooling, which represents a 546% increase in AI tool usage since the start of 2026. But the real meat of this story is how they are applying this across three distinct layers. First, there's the employee layer, where they've moved from simple OpenAI has officially announced that GPT-5.6 is now the preferred model powering Microsoft 365 Copilot. To understand why this matters, you have to look at the scale of the integration. We aren't talking about a standalone chatbot here, we are talking about the AI engine embedded directly into the software suite that runs the modern corporate world. According to the official announcement from OpenAI, GPT-5.6 is being rolled out across Word, Excel, PowerPoint, Chat, and Cowork. OpenAI describes this as their latest flagship model series, and the technical goal here is efficiency. They claim the model delivers more useful work from every token and offers stronger performance per dollar. In plain language, this means the AI is getting better at getting it right the first time. In Word, OpenAI says this translates to drafting and refining documents with fewer rounds of prompting. In Excel, the model is designed to move users from raw data to insights faster by using tokens more efficiently. For PowerPoint, OpenAI has just released GPT-5.6, a new family of models designed to deliver more intelligence from every single token. To understand why this matters, we have to look at the current arms race in AI. For the last year, the industry has been chasing raw power, often at the cost of massive latency and skyrocketing API bills. OpenAI is now pivoting the conversation toward efficiency, essentially trying to prove they can give you more brainpower for less money and time. According to the official announcement, the GPT-5.6 family is split into 3 tiers: Sol, the new flagship; Terra, a balanced model for daily work; and Luna, the cost-efficient option. OpenAI says Sol sets a new standard in coding, science, and cybersecurity, claiming it outperforms competing frontier models while using fewer tokens. The numbers here are specific. On Agent's last exam, which tests professional workflows across 55 fields, Sol hit a score of 53.6. OpenAI claims this eclipses Claude Fable 5 by 13.1 points. Even more striking is the cost efficiency. Sol's medium reasoning mode reportedly beats Fable 5 by 11.4 points at roughly 1/4. OpenAI is officially repositioning ChatGPT from a chatbot into a functional partner for professional labor with the launch of ChatGPT Work. For the last few years, we've treated AI as a place to brainstorm or draft an email, but the industry has been pushing toward agency, the ability for an AI to actually execute a sequence of tasks across different software without a human holding its hand for every single prompt. This is the move OpenAI has been waiting for. According to an official announcement, ChatGPT Work is an agent capable of taking action across your apps and files, breaking complex projects into smaller steps, and completing them independently over the course of several hours. It isn't just generating text. OpenAI says it can create finished materials like spreadsheets, slides, documents, and even web apps. The engine driving this is a new frontier model, GPT-5.6, which is rolling out today. OpenAI claims this model is state-of-the-art for reasoning through multi-step tasks and adhering to specific templates or reference files. Under the hood, this leverages Codex technology. While Codex started as a tool for developers and is still used by 5 million people weekly, OpenAI notes that over 1 million non-developers are now using it for general work tasks. The real-world application here is where it gets aggressive. OpenAI is doubling the payout for researchers who can find universal jailbreaks that bypass its biological safety guards. To understand why this is happening, you have to understand the stakes of frontier models in the realm of biology. As AI gets better at protein folding and genomic sequencing, there is a persistent fear that a model could be tricked into helping a bad actor synthesize a pathogen. OpenAI has been running a targeted bounty to find these holes before someone with malicious intent does. According to an official announcement from July 9, OpenAI is evolving its GPT-5.5 Bio Bug Bounty into a permanent, private initiative called the OpenAI Bio Bounty Program. The core mechanism here is the universal jailbreak. This isn't just a one-off trick, it's a prompt or a method that consistently defeats a predefined bias safety challenge across the model's architecture. To incentivize this high-level red teaming, OpenAI says it is increasing the reward for a universal jailbreak from $25,000 to $50,000. This applies to both the current GPT-5.5 and the newer GPT-5.6. The program is shifting its focus toward the future. While the original GPT-5.5 bounty window closes on July 27, 2026, the new ongoing program will prioritize GPT-5.6 and subsequent. Our approach to government and national security partnerships. OpenAI is sounding the alarm on the benchmarks we use to measure AI coding skills, claiming that a significant portion of the industry's gold standard for testing is actually broken. To understand why this matters, you have to understand how we track agentic coding, the ability for an AI to not just write a snippet of code, but to actually navigate a repository, fix a bug, and verify the fix. For a while, the community relied on SWE Bench Verified, but OpenAI says that one suffered from contamination and design flaws, which led them to encourage a shift toward SWE Bench Pro. But now, in an official research publication, OpenAI says SWE Bench Pro is also compromised. They conducted a detailed audit and estimate that roughly 30% of the tasks in that benchmark are broken. To get to this number, they didn't just glance at the data, they built a quality assurance pipeline. This involved an initial automated filter that flagged 286 potentially broken tasks, followed by a two-pronged verification process. First, they used codex-based investigator agents to probe the repositories in failure modes. Second, they ran a human annotation campaign where 5 experienced software engineers independently reviewed each flagged task. The results were stark. The agent pipeline flagged 27.4% of tasks as broken. OpenAI is moving beyond software updates and into the classroom with a new initiative to help K-12 educators build practical AI skills. For the last couple of years, teachers have been caught in a vice. They are facing rapid technological shifts while dealing with limited time and uneven support. We've seen the headlines about cheating and plagiarism, but the conversation is now shifting toward how the adults in the building actually manage the workload. To address this, OpenAI says it is launching a flagship AI Skills Jam for K-12 educators in partnership with the Walton Family Foundation. This isn't a webinar, it is a series of in-person, hands-on workshops across several U.S. cities, aiming to bring together more than 1,600 teachers, administrators, and district leaders. The mechanism here is a mentor-led approach. Participants work directly with OpenAI mentors to apply AI to the grunt work of schooling, lesson planning, staff and parent communications, and general administrative tasks. The goal is to move educators from mere curiosity to actual practical use. To keep the momentum going after the workshops, OpenAI is plugging these teachers into the OpenAI Academy, which they describe as a free online platform for resources and best practice guidance. Now, let's look at why this matters and what is actually at stake. The core argument OpenAI is making relies on a specific. OpenAI has officially launched GPT-5, a new generation of voice models designed to make talking with AI feel like a real conversation. To understand why this matters, you have to look at how voice AI has worked until now. We've moved from cascaded systems that chain 3 separate models together, speech-to-text, a language model, and then text-to-speech, to turn-based models that processed audio in one go but still required you to stop talking before the AI could respond. OpenAI says GPT-5 breaks that cycle using a full duplex architecture. In plain English, full duplex means the AI can listen and speak at the same time. It isn't waiting for a silence trigger to start its turn. Instead, it's making decisions many times per second on whether to speak, pause, or just offer a conversational aha to show it's paying attention. But the real technical shift here is what OpenAI calls instant delegation. GPT-5 handles the social flow of the conversation, but if you ask it something that requires deep reasoning or a web search, it delegates that specific task to a frontier model, specifically GPT-5.5 at launch, in the background. This means the AI doesn't have to go silent while it thinks or searches. It can keep the conversation moving while the heavier processing happens behind the scenes. Now, let's talk about what this actually means in practice. We are moving away from Mitsubishi UFJ Bank is attempting to move beyond simply using AI as a tool, aiming instead to become a fully AI-native organization through a deep partnership with OpenAI. To understand why this matters, you have to look at the scale. MUFG is one of Japan's largest financial groups. In a sector as conservative and regulated as global banking, the jump from experimenting with a chatbot to AI native is a massive cultural and operational leap. According to an official announcement from OpenAI, this transformation began in October 2024, but the real scale hit in 2026. That is when Mitsubishi UFJ Bank started a phased rollout of ChatGPT Enterprise to approximately 35,000 employees. Now, the how here is what's interesting. They didn't just hand out logins. OpenAI says they worked directly with MUFG on security requirements and product updates to clear the governance hurdles that usually kill AI projects in banking. They also made training mandatory. Employees had to complete e-learning before they were even granted access. The results are already showing up in the data. OpenAI reports that training participation hit 100%. More impressively, after custom GPT training, employees built more than 1,800 custom GPTs, which they call AI Bank. Australian Payments Plus is accelerating its operations by integrating ChatGPT Enterprise and Codex into its core workflows. To understand why this is a big deal, you have to understand what AP Plus actually does. They operate the payments and identity infrastructure for all of Australia. They are the connective tissue for millions of daily transactions, managing everything from scheme rules and cybersecurity to regulatory expectations. In an environment where a single timestamp error can derail a reconciliation, the cost of a mistake is massive, but the volume of technical documentation is overwhelming. OpenAI says that AP Plus is using these tools to solve a knowledge work problem. Specifically, employees are using ChatGPT Enterprise to synthesize dense technical specifications and scheme rules, turning them into clear member-facing guidance. According to the company, 77% of surveyed employees are saving more than 2 hours every week. But the real heavy lifting is happening with Codex. AP Plus is using it for deep technical forensic work. In one specific instance, they used Codex to trace a timestamp inconsistency across system logs and reconciliation data. This reduced an investigation that typically took 4 hours down to just 30 minutes. They're also using it to build functional products. The cost of intelligence is effectively crashing toward zero. That is the core premise of a new perspective piece from the Berkeley Artificial Intelligence Research Lab, arguing that we are entering an era where the cognitive power required for the vast majority of knowledge work is becoming virtually free. To understand why this matters now, we have to look at the collapse of inference pricing. In early 2023, GPT-4 class capabilities cost roughly $30 per million tokens. Today, that same performance runs for under $1, with some providers pushing that even lower, below 10 cents. We are seeing annual price declines between 9x and 900x, with a median drop of around 50x. The Berkeley team argues that this price drop changes the very nature of how we build data systems. They break this down into 3 shifts: systems for agents, of agents, and by agents. First, Microsoft has just expanded its Aurora Earth System Foundation model, releasing Aurora 1.5 as an open-source project designed to scale weather and climate intelligence for researchers and enterprises. To understand why this matters, you have to understand the shift in how we predict the weather. For decades, we relied on physics-based numerical models, essentially massive sets of equations. Now, we are moving towards foundation models, which are AI systems trained on vast amounts of historical data that can be fine-tuned for specific tasks. Microsoft Research AI for Science first introduced Aurora in 2024, and by 2025, they published the findings in Nature, proving a single model could handle everything from ocean waves to atmospheric chemistry. Now, Aurora 1.5 takes that research and turns it into a practical tool. The breadth update is significant. They've added 22 new weather variables to the original 4. We're talking about surface, pressure level, wind, temperature, humidity, precipitation, and radiation fields. They've also moved to hourly temporal resolution, which allows for much finer detail. Think of the exact moment a tropical cyclone makes landfall or the precise onset of rain. But the real technical leap here is the addition of probabilistic ensemble forecasting. In plain English, weather is chaotic. Microsoft Research has introduced Flint, a new visualization intermediate language designed specifically to help AI agents create polished, professional charts without the typical coding errors. For years, we've had a fundamental tension in data viz. If you use a simple command, you get a generic, uninspiring chart. If you want a high-end, polished visual, you have to write verbose, fragile code that is incredibly easy to break. As we move toward a world where AI agents, not humans, are writing this code, that fragility becomes a massive bottleneck. Microsoft describes Flint as a way to bridge this gap. Instead of forcing an AI to manage low-level parameters for axes, spacing, and scales, Flint uses a compact, human-editable specification. The magic happens in the compiler. Flint leverages semantic types to understand what the data actually represents. For example, if a field is labeled as year, month, or profit, the compiler doesn't just treat them as strings or numbers. It uses that semantic meaning to automatically choose the correct temporal parsing, the right color schemes for positive or negative values, and the appropriate baselines. Crucially, Together AI is launching a new inference form factor called provision throughput, designed to give companies guaranteed capacity for open-weight models. To understand why this matters, you have to look at the current divide in AI infrastructure. Right now, if a company wants to use open models, they usually have to choose between serverless options, which are convenient but best effort, meaning they can be unpredictable under heavy load, or dedicated inference, where you rent the actual GPUs. Dedicated is powerful, but it requires GPU-hour math and complex infrastructure management that most software teams just don't want to deal with. Together AI is claiming to bridge this gap. According to their official announcement, provision throughput allows customers to buy provision throughput units, or PTUs. Instead of managing a server, you are buying a guaranteed rate of tokens per minute held exclusively for your use, backed by a 99% uptime SLA. Here is how the mechanism actually works. It's a token-based capacity agreement. Each PTU is priced at $0.05 per minute. However, not all tokens are created equal. Input, cached input, and output token. Researchers have introduced UniClaubench, a new universal benchmark designed to test how proactive AI agents actually handle real-world tasks. For the last few years, we've seen a surge in multimodal large language models that claim they can operate tools and assist users in the wild. But there's a problem. We've been testing these agents in sandboxes, controlled, artificial environments that don't reflect the chaos of a real computer or a real workflow. This has created a gap between a model's benchmark score and its actual utility when you put it to work. To fix this, the team behind UniClaubench has moved away from scenario-based testing and toward what they call a capability-driven approach. Instead of just asking an agent to book a flight, they've broken down agent intelligence into 5 foundational capabilities: skill usage, exploration, long-context reasoning, multimodal understanding, and cross-platform coordination. They built 4. We are seeing a shift in how AI thinks, moving from text-based logic to what researchers are calling chain-of-frame reasoning. For years, we've relied on chain of thought, where a model writes out its steps in text to solve a problem. But video generation is different. It's not just about making a pretty clip, it's about whether a model can actually simulate the logical consequences of an action over time. The problem is that most video models are trained on general footage, basically just watching the world, without any specific guidance on how to reason through a sequence of events. To bridge this gap, a team of researchers has introduced OpenCoF. This is a framework designed to teach models to reason visually. The core of this project is the OpenCoF 17K dataset, which consists of 17,000 reasoning videos spanning 11 different task families. The researchers used this data to create OneCoF. Ideas have genomes, benchmarking scientific lineage reasoning and lineage-grounded idea generation. A new research paper warns that having a highly accurate score model during the training process doesn't actually guarantee that your AI will be numerically stable when it comes time to generate an image or a sample. To understand why this matters, we have to look at how diffusion models work. They are trained using score matching, which essentially teaches the model to reverse a process of adding noise. The industry assumption has been that if the model is accurate during this forward noise process, the reverse sampling process, where the actual AI generation happens, will be stable and reliable. But Iwei Zhou's research challenges that core assumption. The paper demonstrates that a model can have an arbitrarily small error during the forward marginals, yet still fail catastrophically during sampling. Here is the technical breakdown. The author constructed a smooth score field where the forward marginal L2 error is tiny, and the reverse time process is non-explosive. However, When you apply the standard Euler-Maruyama discretization, which is the actual math used to step through the sampling process, the results diverge. Researchers have just released Multi-T-Pop, a new dataset designed to push the boundaries of how AI handles the complex task of multi-track music transcription for pop songs. To understand why this matters, you have to understand the transcription gap. For years, AI has been decent at transcribing a single instrument, but when you throw in a full pop production, drums, bass, vocals, and synths all fighting for space, the models often collapse. We've lacked high-quality, aligned data to train these systems on actual pop music, and that's exactly what this team is trying to fix. According to a paper published on July 9, 2026, Multi-T-Pop consists of 572 segments of popular music, totaling 3.5 hours of audio. The scope is impressively wide, covering diverse genres in decades ranging from the 1930s all the way to the 2000s. The way they built this is the key technical detail. They didn't just record new songs, they performed metadata-based matching using existing song segments from the LAC MIDI and TheoryTab datasets. Researchers have introduced a new method called SLORR, which stands for Simple and Efficient in Training Low-Rank Regularization, designed to make neural networks easier to compress without killing their accuracy. To understand why this matters, you have to understand the struggle with model compression. Usually, we try to factorize a model after it's trained, essentially trying to simplify the math of the weight matrices to save space. The problem is that modern models aren't naturally built for this. If you compress them too aggressively after the fact, the performance usually tanks. The authors, David Gonzalez Martinez and Shirwei Liu, argue that existing ways to fix this during training are too clunky. They point out that current regularizers often require SVDs, singular value decompositions, of massive weight matrices, or they force you to change the model architecture by adding new trainable parameters. SLORR takes a different path. It is a stateless, architecture-preserving framework. In plain English, it doesn't change how the model is built, and it doesn't need to remember previous. We are finally getting a look at how students actually use AI assistants at scale, rather than just relying on what they tell us in surveys. For the last couple of years, the conversation around AI in the classroom has been dominated by shadow AI, students using tools in secret or small-scale pilot programs with a few dozen participants. But as universities begin to officially integrate these tools, we're moving from anecdotal evidence to hard data. A new paper published on AR14 by Christina Schaaf and her colleagues provides a massive descriptive analysis of an AI-based learning assistant called Cynthia. Instead of asking students if they liked the tool, the researchers looked at objective log data from 77,543 students enrolled in distance studies. The mechanism here is a large-scale descriptive analysis. This means the researchers aren't just looking at a general average, they are slicing the data by gender, age group, study cluster, degree, and study mode to see exactly who is leaning on the AI and who is ignoring it. The paper concludes that Cynthia has already. We are seeing a new way to look at high-dimensional data by shifting our focus from the final image to the hidden architecture behind it. Specifically, a new paper suggests that the real value of UMAP, one of the most popular tools for visualizing complex data, isn't actually in the 2D map it produces, but in the internal graph it builds to get there. To understand why this matters, you first have to understand the lie of dimensionality reduction. When we use UMAP to squash thousands of dimensions down to a flat 2D plot, we inevitably introduce distortion. We lose the precise relationships of the original space just to get a picture we can actually look at. The authors, including Duan Hongqiao and Fred Homan, argue that we've been ignoring the k-nearest neighbor or KNN graph that UMAP constructs internally. This graph is the raw blueprint of the data manifold in its original high-dimensional space, created before the 2D projection happens. The researchers demonstrate that by applying standard network science algorithms to this internal graph, we can extract insights that a 2D plot's Autopilot VQA, benchmarking vision language models for incident-centric dashcam understanding. Researchers have introduced a new framework called ARDY that enables high-fidelity, real-time 3D human motion generation that can be controlled on the fly via text and kinematic constraints. To understand why this matters, you have to look at the current divide in digital animation. Right now, we have offline methods that are incredibly precise but too slow for live interaction, and online methods that are fast enough for real-time use but often struggle with complex instructions or lose their way over long periods. ARDY is designed to bridge that gap, making it relevant for everything from AAA gaming to humanoid robotics. The technical core of ARDY is a hybrid representation. Instead of treating the whole human body as one big chunk of data, it separates the motion into explicit root features, which handle the overall trajectory and position, and a latent body embedding for the actual movement of the limbs. This allows the system to maintain precise control over where the character is moving while still using the efficiency of generative learning for the how of the movement. The authors describe a two-stage. We are seeing a shift in how we think about AI agents, moving toward a concept called workflow as knowledge, where the process of doing work is treated with the same permanence as the data it produces. Right now, most LLM applications rely on explicit workflows to handle things like tool use, retrieval, and human approvals. Usually, these workflows are just pipes. They move data from point A to point B, and once the task is done, the execution trace is essentially a log file. But as these systems get more complex, we're hitting a wall where we can't easily inspect or resume these processes without losing the mental state of the AI. A new paper from Emanuele Quinto and his colleagues proposes a way out of this by treating workflows as persistent knowledge objects. Instead of just running a script, they suggest a model inspired by Lisp, using concepts like symbolic forms and live-image thinking. Here is how it actually works. The researchers propose a shared knowledge substrate. In this environment, everything, the workflow definition, the specific instance of a run, the inference records, and even we are currently operating under an illusion of equivalency when it comes to how we shrink large language models for deployment. For years, the industry has relied on post-training quantization to squeeze massive models into resource-constrained hardware, usually judging success by whether the accuracy or perplexity stays roughly the same. But a new paper from Baharababa and colleagues suggests that these standard metrics are lying to us about what is actually happening inside the model. The researchers argue that a model can maintain its overall accuracy score while fundamentally changing its behavior. To prove this, they introduced a new decision-level metric called correctness agreement. Instead of just asking, "Is the answer right?" this metric measures the overlap and correct predictions between the original base model and its quantized versions. When they tested multiple models and quantization schemes ranging from 8-bit all the way down to 2-bit, they found a disturbing trend. Behavioral divergence emerges under moderate quantization even when the task performance looks preserved. In plain English, the quantized model. We have a new understanding of why some AI parameters are critical, but we've also discovered that those same parameters are almost impossible to train in isolation. For a while now, researchers have been hunting for superweights, those rare, individual parameters in a large language model that, if removed, cause the model's performance to crash by orders of magnitude. The logic was simple: if these specific weights are the keystones of the model's intelligence, then targeting them during fine-tuning should be the most efficient way to update a model. But a new paper accepted at the 2026 Conference on Language Modeling tells a very different story. The researchers, including Shreya Subramanian and his team, tested whether super-weight-aware training actually works. They tried training these critical parameters in isolation, testing groups ranging from 100 up to 8,192 parameters on the ALMO 1B and ALMO 7B models. The result wasn't just a failure, it was a total collapse. Training only these superweights dropped model accuracy down to random guessing levels. We have to stop confusing agreement with truth when we use AI to label data. For a long time, the industry standard for proving an LLM is a good annotator has been simple: if the AI's labels match a human's labels, the AI is considered successful. But a new paper by Manuel Pita argues that this is a dangerous oversimplification. To understand why, we have to look at national models AI built for specific linguistic communities. The focus here is AMALIA, a publicly funded, 9 billion parameter model designed for European Portuguese. On the surface, AMALIA looks like a winner. When asked to code the moral foundation of authority, it agreed with trained human coders within 6F1 points of open models that are 8 to 13 times its size. But the researcher asks, is the model actually understanding the theory of authority, or is it just using correlated shortcuts? We are seeing a new push to turn simple 3D skeletal tracking into actual medical and athletic intelligence. For years, AI has been great at pose estimation, basically drawing a stick figure over a human in a video to show where the joints are. But there is a massive gap between knowing where a joint is located in 3D space and understanding the actual biomechanical forces, loads, and activations happening inside the body. This is the difference between seeing that a knee is bending and knowing if that bend is putting dangerous pressure on a ligament. In a new paper, researchers Ada Egbalian and Kevin Desai introduced something called Biomodule. Biomodule is designed as a lightweight, plug-in temporal transformer. Think of it as a specialized translator that sits downstream of any existing 3D pose estimator. It takes the standard 17-joint 3D skeletons produced by those models and predicts biomechanical attributes from them. The technical heavy lifting here is in how they trained it. The researchers built a large-scale aligned dataset by pairing human 3.6. Researchers have introduced a new framework called Latent Memory Palace, which treats robotic reasoning and control as a form of autoregressive variational inference. To understand why this matters, you have to look at the current gap in AI. We have large language models that can think through a problem using a chain of thought, but transferring that kind of deliberation to a robot arm or a drone is incredibly hard. If a robot tries to reason using words, it loses the spatial granularity and the precision needed for actual physical motion. The authors, including Chuning Zhu and colleagues, propose a middle ground. Instead of reasoning in English, the Latent Memory Palace, or LMP, organizes information in an autoregressive latent space. Think of it like a mental map where the AI doesn't just trigger a reflex, but iteratively retrieves information to refine its action. Technically, the paper formulates this reasoning as variational inference. They've developed a latent space reinforcement learning technique to optimize what they call the variational lower bound. This allows researchers have developed a new deep learning framework designed to cancel narrowband interference and perform soft demodulation simultaneously in OFDM systems. To understand why this matters, you have to understand the noise problem in wireless communications. Orthogonal frequency division multiplexing, or OFDM, is the backbone of how your phone and Wi-Fi handle data. But when narrowband interference, essentially strong, concentrated signals from other sources, hits those subcarriers, it doesn't just add noise, it corrupts the data in a way that makes traditional recovery methods fail. The problem with current solutions, according to the paper, is a pipeline mismatch. Most systems use compressed sensing to mitigate interference, but this is slow and leaves behind non-Gaussian residuals. In plain English, the cleanup isn't perfect, and the leftover mess confuses the decoder, leading to error floors where the signal Researchers have introduced a new way to stop AI agents from forgetting critical details during long-term tasks, using a system they call a proactive memory agent. To understand why this matters, you have to look at how current AI agents handle long-horizon tasks, things that take dozens or hundreds of steps to complete. As an agent works, its trajectory or history grows. Eventually, the most important facts, like a specific password found 10 steps ago or a failed attempt at a subgoal, get buried deep in the context window or pushed out of it entirely. The authors of this paper call this specific failure mode behavioral state decay. Instead of just giving the agent a bigger memory bank and hoping it finds what it needs, this team developed a separate, plug-and-play memory agent that runs alongside the main action agent. This memory agent doesn't just store data,
it actively monitors the trajectory and maintains a structured memory bank.
The key mechanism here is selective intervention.
The memory agent decides in real time whether to stay silent or to inject a specific. Researchers have introduced LTM, a new large-scale terrain model designed specifically to map wildfire-prone landscapes with high precision. To understand why this matters, you have to look at the gap in how we currently map dangerous terrain. For emergency response, you need a 3D map to assess hazards, but the gold standard airborne LiDAR is too expensive and updated too infrequently to be truly agile. On the other hand, image-based reconstruction is cheaper, but it often fails in the wild because these landscapes have sparse visual features and limited image overlap, meaning the AI can't find enough landmarks to stitch the 3D map together. The paper describes a multimodal framework that solves this by using outdated digital elevation models, or DEMs, as a geometric foundation. Instead of trying to build a 3D map from scratch using only photos, LTM uses these legacy DEMs as a prior. The core technical breakthrough here is a physics-based pixel-pixel alignment between the new images and the old DEM data. By aligning the pixels based on the physics of the terrain, researchers have developed a new system called MP-Flow that uses deep graph reinforcement learning to optimize how liquidity is placed across the Bitcoin Lightning Network. To understand why this matters, you have to understand the Lightning Network.
It's a Layer 2 scaling solution for Bitcoin that allows for fast, cheap payments by opening channels between users.
But these channels require liquidity, actual Bitcoin locked in the channel, to move payments. If a node wants to route a payment but doesn't have enough liquidity in the right direction, the payment fails. The core problem for any node operator is deciding exactly where to put their limited Bitcoin to maximize their ability to route payments for others. In a new paper, Harrison Rush and his team frame this as a budget-constrained combinatorial optimization problem. Essentially, if you have a fixed budget of Bitcoin, which specific channel should you open to maximize your max flow? Do you actually need a massive, expensive frontier model to verify if an AI's citations are accurate? That is the central question of a new paper from researchers including Ethan Leung and Elias Loomer, who benchmarked how different LLMs perform when acting as judges for source attribution in deep research systems. To understand why this matters, you have to look at how modern deep research AI works. These systems don't just guess, they search for information and then write claims backed by citations. To make these systems better, developers use reinforcement learning, or an LLM judge scores the AI's work based on a rubric. That score then becomes the reward signal that trains the model to be more accurate. If the judge is wrong or biased, the model learns the wrong things. The researchers tested 8 off-the-shelf LLM judges from 3 different model families. They used an adversarial long-form benchmark consisting of 1,248 rubric decisions, all reviewed by humans. They specifically looked at 2 dimensions: source relevance, whether the cited source actually. Researchers have introduced a new system called ProjAgent that changes how AI handles repository-level code generation by focusing on procedural similarity rather than just keywords or semantics. To understand why this matters, you have to look at the struggle of generating code within a massive, existing codebase. It's not just about writing a function that works in isolation. The AI has to respect cross-file dependencies and project-specific conventions. Usually, AI tools try to find helpful examples in the repo by looking for similar words or structures, but that often misses the mark if the logic is similar but the naming conventions are completely different.
Enter ProjAgent.
According to a paper published on July 9, 2026, the system moves beyond simple lexical or semantic searches. Instead, ProjAgent decomposes the target function into a series of intermediate reasoning steps. It then uses an agentic workflow to hunt for other functions in the repository that exhibit similar procedural behavior at each of those specific steps. Essentially, researchers are now digging into the actual trade-offs of relaxed speculative decoding to see if the speed gains are worth the potential hit to model quality. To understand this, we first have to look at how standard speculative decoding works. Normally, you have a massive, slow LLM and a tiny, fast drafter model. The drafter guesses a few tokens, and the big LLM verifies them all at once. In a lossless setup, if the LLM disagrees with a guess, it corrects it perfectly so the final output is exactly what the big model would have produced alone. But recently, some have argued that if we relax that strict requirement, essentially allowing the drafter to have more influence over the final result, we can get even faster speeds or even capability gains. In this new paper, Xia and his colleagues conducted a practical investigation into these training-free relaxed techniques. They unified several existing approaches into one framework to benchmark how they actually perform in the real world. Their findings highlight a critical technical friction point. While lossless decoding is a drop, researchers have introduced Solar Chain Eval, a new physics-constrained benchmark designed to test whether AI agents can actually be trusted to manage decentralized energy markets. To understand why this matters, you have to look at the shift toward agentic AI systems that don't just chat, but actually execute actions in the physical world. In a decentralized energy grid, these agents are tasked with balancing power supply and demand. If an AI makes a mistake in a chatbot, it's a hallucination. If it makes a mistake in a power grid, it's a blackout or a physical failure. The researchers, Sherlin Oh, Yifan Su, and Luyao Zhang, built Solar Chain Eval as a gymnasium-compatible Markov decision process where agents make decisions on an hourly basis. Instead of just measuring if the agent made money, the benchmark evaluates 6 distinct dimensions: market utility, physical safety, slippage, action smoothness, spatial fairness, and auditability. The technical core here is the planner/auditor layer. The planner uses a large language model to set action bounds and resample or reroute. Budget-aware test-time model selection for large language models. Researchers have introduced WebSwarm, a new framework designed to move AI web search away from simple fact-finding and toward complex, research-oriented tasks. For a long time, we've relied on React-style agents. These are the bots that think, act, and observe in a linear loop. But as we ask AI to do more heavy lifting, like deep-dive market research or comprehensive literature reviews, those linear paths break down. They run out of context window or get lost in a single long trajectory, forcing a trade-off. You can either go deep into one topic or wide across many, but doing both at once is a struggle. WebSwarm solves this by using what the authors called progressive recursive delegation. Instead of one agent trying to do everything, WebSwarm dynamically creates agentic search nodes. Think of it like a corporate org chart that builds itself on the fly. Each node is given a local objective and a specific search mode that dictates how it should collaborate. Here is the key mechanism: a node can either solve its task directly or, if the task is too complex, it can delegate further by. A new framework called EdgeRefine is attempting to solve the long-standing tension between keeping graph data private and keeping it useful for AI. To understand why this matters, you have to understand how graph neural networks, or GNNs, work. They learn from the connections between nodes, like people in a social network or proteins in a biological system. The problem is that the very structure of these connections can leak sensitive information. If an attacker can figure out who is connected to whom, they've essentially breached the privacy of the entire network. Traditionally, to protect this, researchers use edge-level differential privacy. In plain English, they inject noise into the graph's adjacency matrix to hide whether any single edge actually exists. We are looking at a new study on how to keep AI-driven markets from collapsing when the agents involved are purely self-interested and prone to betrayal. As we move toward autonomous agent economies, there is a fundamental fear that these systems will devolve into social dilemmas, essentially, a race to the bottom where agents stop cooperating and start defecting to maximize their own short-term gain. This research aims to find the specific guardrails that can prevent that total systemic failure. To test this, researchers Eugene Sheng and Bingquan Shin built a marketplace simulation using 18 DeepSeek v3 LLM agents. These agents weren't identical, they had complementary production specialties, meaning they had to trade with one another to actually obtain utility. The study ran two distinct phases. First, they compared 8 different formal mechanisms across 200 rounds, while progressively injecting trolls into the system to see which structure held up best. The clear winner here was mediation. To explain how this works, instead of letting agents trade in a chaotic free-for-all, researchers have proposed a new framework called GSPDAGFL that aims to make decentralized AI training more secure by using virtual voting to weed out bad actors. To understand why this matters, you first have to understand the tension in federated learning. Normally, you have a central server coordinating a bunch of devices to train a model. Decentralized federated learning, or DFL, tries to kill that central server by letting nodes just gossip updates to their neighbors. But that creates a massive security hole. How do you know if a node is lying, lazy, or actively trying to poison the model? In a new paper published on AR14, authors Amir Hossein Taherpour and Xiaodong Wang introduced GSPDAGFL to solve this. Here is how the mechanism actually works. Instead of relying on a slow blockchain or a central committee to verify updates, GSPDAGFL uses the gossip history itself to reach